Okay, now we're going to talk about lines on spheres. I know I just explained how the Earth isn't a perfect sphere, but we're going to ignore that for now and go back to pretending that it is. So if you were looking at a sphere, such as this, the only thing that you could really realistically argue counts as a line is something called a great circle. And what a great circle is it's an arc that goes and wraps around the full circumference of the sphere. It has to go wrap along the widest possible course it can take without changing direction at any point other than, turning to remain along the plane of the sphere. So if, for instance, you were to make a really small arc like that, that doesn't count because that doesn't wrap around the full circumference of the sphere. That's what's called a small circle. But if you take a course that follows the widest possible circle that you could make along this sphere, that is a great circle. And that is also technically the shortest distance between 2 points. If instead of going the whole way around, you just went from here to here, taking a great circle track where you follow a segment of the total great circle is the shortest possible route you can take to get from one point to the next. And that's what makes it essentially the only thing that approximates a line when you're talking about geometry on a sphere. Now, the other type of line that we work with a lot is called a Rhumb line. The difference between a Rhumb line and a great circle is a Rhumb line is a straight line only within the context of a Mercator projection chart. So on a Mercator chart, a Rhumb line will look like a straight line. But a great circle track on a Mercator projection will actually look like an arc, like that. Even though this is actually the shorter route to follow, this looks straight. If we were to plot them on a sphere again, the great circle track would look straight, and a Rhumb line, and I'm going to explain why in the next video, but a Rhumb line would actually look like a spiral that spirals up to the north or the south pole. As evidence that it's not actually a straight line. We don't follow great circle lines, even though it's the shorter route, because you can't pilot a ship along a curve. You have to pilot a ship in a straight line. It's not realistic to do this. But, and we'll go on to this into detail on this later on, what you can do is a series of straight lines that approximates a great circle track. Once we get towards the CELNAV side of things, we'll learn how to calculate that and how you can approximate a great circle as best you can. But especially when we're on short distance voyages, people just take straight lines because that's what you can follow along a chart.